And we're back with classifying triangles and angles of triangles. Anybody else see the minions and immediately start doing the ba-na-na, ba-na-na-na? Yeah, sorry, annoying. Anyway, we're looking at triangle classification by their angle measures. So an acute triangle, if you hadn't figured it out, it's all acute angles, which means that all angles are less than 90 degrees. Equiangular or equiangular triangles mean all angles are equal. Mrs. Coyle had a very hard time reading that, apparently. A right triangle has one right angle. And an obtuse triangle has one obtuse angle. So when we look down here at our examples, if we're going to classify them, first of all, I see this 90 degrees. That makes it a right triangle. Not all of them are the same. I do see an obtuse angle. Obtuse means it's greater than 90. So this is an obtuse triangle. Triangle. Misspelling things now. And over here we've got 60 degrees, 28 degrees, and 92 degrees. Now, doesn't look like it, but that 92 degrees means it's obtuse, so it is an obtuse triangle again. And let's flip it over. All right. So what if we're talking about side lengths? Equilateral triangles, all sides are the same. All sides are the same in an equilateral triangle. Isosceles triangles have two sides that are congruent or equal. And scalene triangles, you've probably heard me talk about this in class a little bit, is no sides have the same measure. All right, so if we look down here at these triangles, we've got a 4, 4, 5, which makes this isosceles. We got a 3, 3, 3, which makes it equilateral. And over here, we see that we've got 1 line, 2 lines, and 3 lines. It doesn't tell us the measurements, but because each of these is different, that tells us that it is scalene. So over here, we could mark the same thing on our scalene triangle, so we remember that's what that means. All right. The next thing we need to remember is that the angle sum of a triangle, all our angles, in other words, will add up to equal 180 degrees. So if we're looking at example 1, all 3 of these need to add up to be 180 degrees. So in other words, 55 plus 79 plus x is equal to 180. So in order to figure that out, we add 55 plus 79. Which is 134. And we subtract that from 180 to figure out what x is. So 180 minus 134 gives us that x is equal to 46 degrees. If you wanted to check that, you could actually plug in 55 plus 79 plus 46, and it gives you 180. All right, over here, it only tells us that we're trying to find the one angle of an equilateral triangle. Now here's the good news. if it is equilateral, it is also equiangular. So all we need to take is 180 is equal to 3 times x. So 180 divided by 3 will give us our angle measurement. So our angle, x, is equal to 60 degrees. Over here we've got an isosceles triangle, isosceles right triangle. So we know that over here is 90 degrees. And this is isosceles, which tells us that both this angle and this angle are equal. So we've got 2x plus 90 is equal to 180. So I'm going to go ahead and subtract 90, which gives me 2x is equal to 90. Divide 90 by 2, and I'm going to get that x is 45 degrees. All right, just like when we were solving equations, we're just taking the time to break apart the steps in order to get those measurements. All right, last page. Find the side lengths of the triangle below. So we are not only trying to find all of this, we're given the perimeter when you add all the side lengths, but it's also like an equation. So we have 3y plus 8 plus 2y plus 6 plus y plus 3 is equal to 137. All right, if I actually combine like terms, I've got 3y, I've got plus 2y, and I've got y. 3 plus 2 plus 1 is 6y. Then I got 8 plus 6 plus 3, which would be 17. And that is equal to 137. So I'm going to subtract 17. So we got 137 minus 17, which is 120. And I'm going to divide 120 by 6. So y is equal to 20. Now we have to plug y in order to find side AC. So it's 3 times 20 plus 8. 3 times 20 is 60, plus 8 is 68. So we got 68 over here. I need centimeters. 2 times 20 plus 6. 2 times 20 is 40, plus 6 is 46, so that is BC. And then we got y plus 3, so 20 plus 3 is 23 centimeters, and that gives me side AB. All right. So on part B, it tells us that we've got an isosceles triangle. It doesn't tell us the whole perimeter, but it does tell us that 2y plus 8 is equal to 18. So we got 2y plus 8 equals 18. So I'm going to subtract 8. Now I got 2y is equal to 10. So y is 5. So in other words, side AC is equivalent to side BC, so that is 18. Side BC is marked as 18. Side AB, I need to plug in 3 times 5 minus 4. 3 times 5 is 15. Minus 4 is 11. The triangle inequality theorem. The triangle inequality theorem is that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in other words, if I add A plus B, it has to be greater than C. B plus C must be greater than A, and A plus C must be greater than B. So no matter which two sides I add, it has to be greater than the other side. So if I come over here and I say, okay, 1 plus 2 has to be greater than 5. Is that true? Well, no, 3 is less than 5. So this is not a triangle. If I come over here, 4 plus 2, is that greater than 5? Yeah, it's 6, so that works. 2 plus 5 has to be greater than 4, which is 7, so that works too. And then 5 plus 4 has to be greater than 2. And that definitely works because that's 9. So this is a triangle. Is 3 plus 2 greater than 5? Remember, greater than, not greater than or equal to. So no, this does not make a triangle because it cannot be equal. It has to be greater than. All right. Over here we got 5 plus 7. Is that greater than 12? Nope. It equals 12. Over here we got 6 plus 8. Is that greater than 10? Yes. Is 8 plus 10 greater than 6? Yes. Is 10 plus 6 greater than 8? Yes. So this is a triangle. Is 2 plus 2 greater than 2? Yes. And that's going to work no matter what because all of these are the same. So this is a triangle. All right, guys. I hope you got the gist of this. We're going to continue working with this for a couple days. Make sure to ask your teachers if you got any extra questions. Bye.